Today on the Clean Power Hour, thermal power. We don't talk a lot about thermal power on the Clean Power Hour, but it's a thing. And we have two experts on the show today. I'm so pleased to bring some fellow podcasters and an engineering firm called CEM Engineering onto the show today. Welcome to the show, Matt Lensink and Lisa Katz.
Thank you, Tim.
I learned about you guys from your podcast, Energy Radio, so I encourage our listeners to check that out. And Matt is the CEO of CEM Engineering. Lisa is the Director of Business Development. And we're going to be talking about what you guys are up to in the thermal space. There's a lot of dynamics going on in that space. So looking forward to digging into that and reflecting a little bit on what's going on in North America and perhaps the world. So do us a favor, though, and give us a little background on yourselves. How did you get into energy? And then, what is going on at CEM?
You want to go first, Matt?
No, ladies first, Lisa.
All right. So, obviously, Lisa Katz, Director of Business Development and Marketing here at CEM Engineering. So I actually am fairly, in quotation marks, new to the energy space. So I came into energy about 5 years ago. Before that, I was in the environmental side, so environmental controls. Worked for a company called DCL International for about 9 years. So I was basically equipping equipment such as construction or mining applications with emissions control, gas compression applications. I was also working in the yachting sector for a number of years. So lots of different applications that I was essentially outfitting with those types of controls to get them to be emissions compliant for those specific, geographical areas that we were serving. And then I worked for a heat recovery steam generator company and a simple cycle catalyst company called Express Integrated Technologies. Unfortunately, they're no longer around, but worked with them for a very short stint. And then joined CEM about 5 years ago. Actually, come this December, it'll be 5 years. And have had a blast ever since. Got exposed to engineering for the first time in a way, and EPC projects. It's been fun. But that's sort of how I kind of worked my way into the energy space.
Very good. And yourself, Matt?
Yeah. So background on me: I'm a father of three, husband of one. Here, a mechanical engineer. And my journey to the energy industry was most of my life. And what I mean by that is I grew up in a house. My father was a mechanical engineering technologist, and as long as I can remember, was involved in the hydroelectric industry. And whether that was commissioning hydroelectric turbines all over the world, or then for the last almost 30 years now, working for a large independent power producer, Liberty Power, and doing hydroelectric, doing wind, and doing solar. And so I have many memories of family vacations that involved at least one day to a local hydroelectric facility, a local dam, to see the sites. And so that was kind of the world I grew up in, and then went on to study mechanical engineering. Knew I wanted to build and design stuff, and was getting ready to leave university in 08 when the economy was struggling and could not find a job. And my uncle, who started CEM, came to me and said, "Hey, you want to work for me?" And my first answer was no. I don't want to work. I don't want to work for family, and I don't want to be a consultant. And 3 or 4 months later, still no job, upcoming graduation, upcoming wedding, and fortunately the offer was still on the table, and I took it, and it was the best decision I could have ever made. And we have since completed an ownership transition. He's still very much involved in the business, and I now run it day to day. So couldn't have asked for a better career path. So CEM stands for cogeneration and energy management, and we are a thermal power project delivery company, whether it's consulting, design engineering, EPC, design build, in the thermal power space. So we really talk about anywhere there's molecules. So if it's molecules to electrons or electrons to molecules or molecules to molecules, and we can unpack what that means in a bit more detail. But that's the space in the whole broader power space that we work in, and I love the title of this or the name of your podcast, Tim, the Clean Power Hour. And I think our initiative is to clean up thermal power. I mean, thermal power has a history that's a bit dirtier, and we're trying every day to clean that up. So,
yeah, as our listeners know, there's a legacy of fossil energy across the globe, and there are still countries like India and China that are building coal plants. But here in North America, the coal industry is in decline. It's in very steep decline. We are closing, gigawatts and gigawatts of coal plants. Many of them have already been converted to natural gas because natural gas was the first nail in the coffin of coal. It just was cheaper and it was cleaner. And so that was a win-win for the asset owners and the utilities, right? Now there's this, this other wave of newer technologies like photovoltaics and that are, and wind, of course, and now battery storage. We were talking in the pre-show that there's a whole wave of coal to solar going on across the country here in the U.S. So let's talk about cleaning up thermal energy, though. So what is a good opportunity, and what are the types of projects that you're excited about, and what are the technologies involved?
I'll let Lisa talk about some of the exciting technologies and projects. I think it's important, though, before we do that, to talk about thermal power. Like those are great stories about thermal power, coal to PV, coal to wind, and replacing that with the and the storage piece and the electricity. And the reason it's important for us to also clean up the thermal is because there's lots of particularly industrial and institutional processes that require that high grade thermal energy. And so they still need it to, make tissue, or to make, food and beverage, or to heat hospitals or heat university campuses. So part of, and we talked in the pre-show about multiple ways to skin a cat, part of this energy transition is that cleaning up of it, because we still need that high grade heat. And so we're doing a lot of exciting projects, and Lisa can touch on some of the exciting technology and projects that we're working on.
Yeah, and maybe what I'll do is I'll just take you and your listeners kind of a step back, Tim, to kind of give you an idea of where we started, because we're a 20-year engineering firm, 20-year-old engineering firm, and we, as kind of Matt alluded to, we started really in cogeneration and energy management, which of course make up the name of CEM. But we work in a variety of other kind of spaces or with other core competencies. So over the years, we've been we're an engineering firm that's been focused on cogeneration and power generation, district energy, energy management, biomass, biogas, RNG. And now hydrogen. I feel like I'm missing one of them. Maybe it was energy management, actually. But we really, in terms of the space that we've really been operating in, which at least initially has been Ontario, the Ontario market here in Canada, we're really known for cogeneration. But over the last, I will call it 8 to 12 months, the way that our business has started to evolve into more of this renewable space, which includes RNG and biogas and hydrogen, and now some solar thermal stuff, which I'll let Matt talk about. It's really fascinating because the space has just moved so quickly. But and so we're still working on cogeneration and power generation projects, just not as many. And then from a geographical perspective, we're really right across North America. But we have seen a big change in Ontario, specifically with cogeneration, because, as Matt kind of alluded to, earlier, the carbon tax. And so because that's going up to $170 a ton by 2030, it's currently at $40 a ton. There's a lot of emphasis on reducing fossil fuel use. And that's part of the reason that we've seen such an interest in the biogas and RNG market. And the credits or revenue streams that are available in California, different areas of the U.S., and through people in Canada like Energy or Fortis BC, it's tremendous. So we actually have in some ways, unfortunately, people discontinuing the use of their cogeneration facilities and actually injecting that gas from that waste stream, whether it's a wastewater treatment plant or a landfill or an anaerobic digester, and injecting that into the natural gas grid, essentially.
Yeah. And you said something that made my ears prick up. $120 or $130 a ton carbon tax?
Go a little bit higher than that. $170 a ton by 2030.
Because I heard that a magic number is $100 a ton. If the world went to $100 a ton carbon tax, that would accelerate the energy transition tremendously. That was so, you know, we don't have many carbon taxes here in the United States, but give us some background on how long has that been going on, and how is that trending in Canada, and then how does that impact customers and technologies and driving. I mean, hopefully it's driving some kind of change, right? But I'm just curious if you could flesh that out.
Yeah, no, absolutely. So yeah, I'm trying to remember now. It was just earlier this year when really the carbon tax was sort of set in stone by our federal government. And so our Prime Minister, Justin Trudeau, who of course has been reelected, was sort of the one who kind of drove that behavior. And some would say that yes, it is driving positive change. Certainly, if you look at even a CHP business case today, you're seeing the effects of what that would have on the economics. However, I just literally came back from the IPSA conference in Banff, Alberta, and many of the policymakers there are saying $170 a ton isn't even enough. Like they're talking about numbers like $350 a ton to try and get us to kind of transition even faster. And they're saying that that's almost what's required. But there's a lot of opinion on that, and whether that's really needed. Do we just give industry a target and let industry run with it and get government to step out of the way? So it is interesting, but it is definitely playing a big role in terms of the change that we are seeing in our own business. That's for sure.
And mechanically speaking, there's a couple ways how it actually hits the end consumer, but primarily it's hitting the natural gas bill. And so the natural gas retailers are charging for the commodity, they're charging for the transmission and distribution, and they're charging for carbon tax, and it's their obligation to recover that and put it somewhere in the government coffers, and who knows what actually happens with it. And so what we are hearing from, in particular, our industrial client base who are working every day to make a product and do it competitively, and oftentimes competing with larger American or Mexican manufacturing plants, they're telling us that by 2030 they're done. Like if they don't do something about particularly the natural gas consumption, and we're not talking mom and pop shops, we're talking big Fortune 500 companies are saying to us. I just had a conversation yesterday with a large chocolate manufacturer, and they said, we got to figure this out, because if the do nothing case and 2030, when it's $170 a ton, we're out of business. We just can't afford that increase. So it's driving, I would say it's driving some behavior, and it's driving a lot of interest. And I would say by March 31st, it's going to go to $50 a ton. It's going to start to drive some real behavior here in a hurry.
So if we're using natural gas for thermal processes and cogen, how do you decarbonize that process, and what are the trends and technologies that you see coming on as a result of this?
I think there's a basket of solutions, and each user of thermal energy is unique. On the demand side, on the consumption side, we know of a large university, my alma mater actually, and they're going to do a lot of industrial heat pumps. So really trimming their steam load through heat pumps, electric driven heat pumps, and then anything they can't get with the heat pumps, they're going to get with electric boilers. And so they're going to put in the infrastructure, and we're talking megawatts of infrastructure to put in large electric boilers. And then they have a bit of a strategy to deal with some of the demand charges that are going to come along with that. So that's one basket of solutions. Another technology that's really, we hope, coming of age is solar thermal technology. So similar to solar PV, how can we harness the sun's energy to make, high grade hot water or medium pressure steam? And then I would say on the supply side, there is a market for offsets and incentivizing people to generate renewable natural gas, which doesn't have a carbon footprint, generate it at a premium, flow that through the existing natural gas infrastructure, and so these bipartisan or bilateral agreements. You make renewable natural gas, I'll buy it because I still need to consume the molecules. So those are some of the technologies that we're seeing emerge. Did I miss anything, Lisa?
No, I was going to just also just add to your comment about renewable natural gas and hydrogen as well, right? Like there's a lot of talk, not just in Ontario, but I think globally in the hydrogen space. And I was talking with a supplier or a project developer just the other day. They want to put 500 megawatts of basically a hydrogen facility in Quebec because there's cheap power there. So they'll generate through electrolysis hydrogen. And interestingly enough, there's a very big market in Germany. So their thought process was actually to ship the hydrogen across the ocean to Germany instead of using it more locally. But that kind of brings us back to the CHP conversation. Like a lot of people in our industry are wondering, where is CHP going? And some people are saying, oh, it's dead. And, one could argue that, no, it's not quite dead because, if you can use that renewable natural gas molecule, or you can use a hydrogen molecule, whether it's in a gas turbine or an internal combustion engine, you're achieving net zero. And then even if you put carbon capture on top of that, all of a sudden you're now, you're not just net zero, but you're below that, right? So I think it's going to be interesting. It's going to be interesting to see, just how our industry evolves and how we kind of continue to go on this path, and what technologies are also going to be used beyond 2030. Because based on the conference that I just went to, I think it's pretty clear what we as a society, as government, as companies, as engineering firms need to do in terms of a technology, from a technology perspective until 2030. But then there's still a whole slew of different technology that haven't even necessarily hit the market yet that could be used beyond that.
I'm very curious about solar thermal. Here in the US, photovoltaics really knocked solar thermal out of the market, but there's no reason, fundamentally, why you can't use photons to heat water to then assist in heating and other industrial processes. I didn't know that industrial facilities are installing electric boilers, so that's also interesting. And of course, then you can just use any kind of electrons to run that process, and then wind, solar, and batteries become relevant to that. And I do want to drill down on hydrogen also a bit, but let's talk about solar thermal. What do you see happening? You mentioned you're evaluating a Swedish technology. How is that different? What is the next gen solar thermal looking like?
Yeah, what we're seeing and what we're excited about is that there's solar thermal at a utility scale where we're doing solar concentrators, where we're running steam turbines, and we're making utility power. Our excitement is more a step down from that, and there's a Swedish company that we're actually partnering with, and their name is Absolicon, and they have a compact kind of reflector technology where it's a long half of a cylinder with a very reflective material on the inside, reflecting the sun's rays into this collector tube to harness the energy. And very simple design. It does have a tracking mechanism like many solar PV installations. And so whether you do roof mounted or ground mounted with this technology, just a very simple hot water system. You can run it at pressure, at a higher pressure. And so if you need steam, you can also make steam. And so it's not going to take it's not going to eliminate the natural gas purchases at an industrial site. But it is going to displace kind of a minimum base load. And then through energy management, through maybe some electric boilers, there's a complement of technologies. But this company's been developing this technology for the last 15 years or so. Last 5 years has been about commercialization, and we've actually launched a new company here. Phoenix Solar Thermal is the new name, and that will be the local North American representative for the panels, and within the year manufacturing them locally here as well. And gotten some, this is weeks old. This is very, very new, and gotten some really good response from both institutional and industrial clients who say, yeah, that because it's like PV in that it's a simple story, right? Cogen, biomass, RNG. There's a lot of layers to that, and there's a lot of we love it, we live it. It's something that we get our heads around, but for clients and for decision makers, solar thermal is something that's elegant and simple, and it's an easy story to tell, and that's part of, I think, what it takes to develop bigger projects.
You mentioned that there's a tracker technology with this. Is that a single axis or a dual axis tracking technology?
It's a single axis. It sits on a racking, and it kind of goes like this. It does not go like this.
Yeah, gotcha. And so you're anticipating, though, that a customer could supplant their natural gas usage with some solar thermal, and is this like you could sell this into the market next year? It's real. It's in production, or?
Yeah, for sure. We're targeting our first. Targeting to sign up our first pilot/demonstration project, hopefully by Christmas of this year. So in the next several months, with installation planned for the spring, and then on the strength of that, we would proactively go to the market for large projects, and the goal would be that by end of next calendar year, the panels for those large projects are manufactured locally here in Canada is the goal. So and we've done some. We think that so right now in Canada, your thermal energy is probably $5 to $7 an MMBTU once you factor in the cost of the commodity, which has gone up considerably, the transmission, and the carbon tax. But by 2030, that same MMBTU is going to cost you $13, $14, $15. And so we think a levelized cost of this solar thermal can be done between $7 and $12 an MMBTU. So there's a bit of a green premium initially, but once we get past 2030, it's you're saving significant money every MMBTU you generate. So.
Yeah, and Tim, part of the reason that CEM is involved in so many different, or we have so many different core competencies, is because we realize that while solar thermal is great, it might not be, the best for every single geographic region, right? So, Matt touched on this earlier in the podcast, and you were, asking what's new for CEM and what's going to kind of move our space from a global perspective. And that's why I think he was saying also that it's going to depend. It's going to be, a variety of technologies. And the truth of the matter is, it is, right? Like if you look at Alberta, they're coming off coal, they're using natural gas. Yes, they're doing wind and solar, and they're doing some energy storage, but they're also doing a lot of CHP and straight power generation. But you go to Ontario and it's a different story. Now we're talking about more solar thermal and less CHP, again, because of the carbon carbon tax, but also just because it's, natural gas has become a little bit of a bad word here in Ontario. Again, the RNG space and biogas, space is picking up. So that's part of the reason that we're involved in all of these different sectors, because we can address various client needs depending on their geographic region. And we realize that's going to change depending on where they're located.
And are you addressing the entire North American market, or what is your geographic territory?
Basically all of North America. Yeah. We're trying our best. I mean, we are, I will call it, predominantly still involved in projects in Canada. And that's just because of our historic roots. This is where we kind of laid down roots, and this is where we've sort of, evolved the business in Canada, and we've gotten a name for ourselves here. But we actually just more recently closed. I can talk about this project now publicly because it has been publicly announced. In fact, just 2 days ago we announced it. We are doing an RNG project with TECO, or People's Gas, Tampa Electric. Some people know them as well. And that is in the U.S. That is CEM doing an EPC project. So we will do all engineering, procurement of equipment, which will consist really of an RNG upgrader and construction. So that is going to be our first true EPC project in the U.S. that we are doing under CEM Projects, our turnkey division. But we're also working on other projects in the U.S. right now that could take off, any day. And we've worked on, several studies and different opportunities in various areas of the U.S. as well. So.
Great. Well, let's talk about hydrogen. That's, a very hot topic. You can take hydrogen and mix it into traditional natural gas processes and pipelines. Once you hit a certain concentration, of course, then you have to retrofit the pipes, right? Because hydrogen makes pipes brittle. So that is one challenge, but the Europeans are going hard after this. And we are seeing a burgeoning hydrogen economy here in the US. It's just very early stages. You have to look for it. Here in my town of Urbana, we have an electrolyzer, a commercial electrolyzer that is driven by solar PV to fuel electric fuel cell buses that are, using hydrogen. So it's a totally clean process, soup to nuts, when you're making hydrogen from water. Now, there's many ways to make hydrogen. I'm also involved with a company called Ally Power, who's been on the show, and they're using aluminum and sodium hydroxide, which is an exothermic reaction, and then they're using that heat to generate electricity on site, and then storing hydrogen for long-distance trucking applications on the West Coast initially. So in the U.S., we really only have a hydrogen network in L.A. and San Francisco, but now there's companies that are planning to expand that network up and down the West Coast of the U.S. What's going on in Canada? And then how does this impact your business? How do you see commercial industrial applications of hydrogen?
Yeah, hydrogen's one of those, and Lisa and I always joke on our podcast, we kind of, the first time it gets mentioned in the show, we kind of record the time and acknowledge it, because we can't go a show without talking about it. And my line always is that you can't swing a dead cat without hitting somebody who wants to talk about hydrogen. And that's really cool to hear about your own town there having an electrolyzer. And we have, there's one project here north of Toronto that's also, using grid electricity, which in Ontario is very green because of the wind and solar and nuclear and hydroelectric that we have. And they're storing it on site, and they're doing some injection, and they're testing that phenomenon that you're talking about in terms of hydrogen embrittlement and how, even if the pipes are okay, how do the downstream appliances handle, some additional hydrogen in the gas. But in Canada, I would say it's still in that phase of a lot of talk, but a lot of talk in the right direction by the right people. And I think it depends on the geography and the geographical location that the conversation is happening. So in Quebec, primarily, also somewhat in Ontario, there are electrolysis projects, green grid electricity to hydrogen, primarily for either export, as Lisa talked about earlier, or there's a project that there's a project we're bidding into that is a large power producer that wants to make hydrogen for a bunch of different to fuel a gas turbine. So that's the story here in the East. But then in Alberta, and Lisa, maybe you can add to this because you were out there this week. It's a very different discussion, and it's really, I think, fueled by an oil and gas industry in Alberta that is looking forward, saying nobody likes us anymore. Our own countrymen and countrywomen don't like us, even though we bankroll this country in some ways. But people don't like us, so we better figure out how to change because we like our infrastructure. And so through that process, I think Albertans have said, listen, we get this molecules thing. We need to figure out how to be a leader in hydrogen generation. And so I think that's really where the hydrogen rainbow, as it was described at the Department of Energy Hydrogen Shot event that took place, I think, in September, that rainbow is important, right? We talk about gray hydrogen, which is commonplace today, blue, green, yellow, pink, I don't profess to know them all, but I think in Alberta, where there is some infrastructure, there's a lot happening in Edmonton, Alberta, for example, as a hub. And there's some projects already happening where some of the big gas turbine OEMs like Baker Hughes, with Air Products, I think, has launched the project almost exclusively hydrogen fueled power generation. So there is definitely some happening. At least I don't know if you've wanted to add to that in terms of Alberta and what's happening in hydrogen.
Yeah, so actually just to cover off Air Products, so they were actually at IPSA as well. So I met with somebody from Air Products, and they're going to have, I think it's North America's largest gas turbine currently that's running on 100% hydrogen. So as Matt stated, it's a Baker Hughes. I can't remember the model, but it's a 16 megawatt, if I remember correctly. I think its nameplate capacity on natural gas is something like 16.8 megs, but on hydrogen, 100% hydrogen, it's only 16.2, which is actually really interesting because most of the gas turbine manufacturers who are running on or could run on 100% hydrogen, they have a huge D rate, and the same holds true for internal combustion engines. But yeah, the Edmonton Hydrogen Hub is doing a lot of work in terms of trying to connect essentially a decommissioned natural gas line to an existing hydrogen pipeline that's in fairly close proximity. That natural gas line would have to be relined so it could handle the hydrogen, and obviously its corrosive nature. But the idea is that if you could connect those two lines, you are then able to serve a whole bunch of industrial clients within the area. And so there's been a lot of discussion with people like 2G Energy and others who are in the engine or gas turbine business to provide hydrogen solutions to that area, because that would allow the integration of CHP with some very large industrials to achieve their sustainability and carbon reduction goals.
And is your understanding that you can take a natural gas pipeline and reline it from the inside without replacing the pipe? Is that feasible?
That's what through the discussions that I've had with the Edmonton Hydrogen Hub, that's essentially the way that it was explained to me. I can't comment on it any more than that, other than I know that they are trying to actually go after some federal or government funding to do just that. And if they can do that, which is fairly expensive, then and connect that existing decommissioned line to the current hydrogen line, then this would kind of solve a lot of problems within that area. So that's the way that I understand it, Tim.
Gotcha. But so if I'm let's just say I'm a food and beverage manufacturer, and I'm running a lot of processes using natural gas today. Is it conceivable that I will start to use hydrogen in the near future, or are other technologies going to happened before that in terms of decarbonizing their footprint?
My sense is that the hydrogen story is, in that setting, is a longer term story. I think you're right, Tim. There are other technologies that will help either on the energy management side. So if I'm a food and beverage manufacturer, how do I use less thermal energy? I think that's really where we should always start. And then in terms of the generation of that thermal energy, electric boilers, perhaps. And then I think people switch to renewable natural gas before they switch to hydrogen, just because the price point is better. The price relative to fossil gas, the price of RNG is not as much of a premium as hydrogen is today, and it requires no technical change because it's the same molecules that we've always been dealing with.
And then Lisa, you referred to a derating. So when you're using thermal energy from methane versus hydrogen, the energy density of hydrogen is less. Is that what you're referring to in the derating?
Yeah, so the way that I understand it is basically hydrogen, of course, which can be obviously very corrosive. It also increases the combustion temperatures relatively quickly in an engine or even a turbine. That can also increase NOx emissions. So there's a variety of kind of other issues that kind of happen and take place with that. But it's because of that, the thermal increase, from what I understand it, that the engine manufacturers are derating.
It's twofold. It's the energy density and it's the fact that it burns hotter. The two of them require more iron, so to speak, to make the same amount of power. So that's where the derate comes from.
I see. Well, in the last few minutes, tell our listeners how they can find you guys and your podcast.
Sure. So I'm on LinkedIn. So, I'm fairly active there. So just Lisa Katz, you'll find me there. Otherwise, my email address, if you want to reach out directly, is lisa@cemeng.ca. Those are probably the two best ways. But obviously, listening to our podcast, Energy Radio. If you're interested in becoming a guest, we'd love to have you on. We also have other various kind of content streams that you might be interested in. Energy News, Energy Roundtable are two other mediums that we commonly hear about that people are enjoying. So listen into those, and we'd love to hear from you.
Cool.
Wonderful. Well, you can find all of our content at cleanpowerhour.com. I'm Tim Montague. You can reach me on LinkedIn or on Twitter at TG Montague. Please give the podcast a thumbs up, subscribe to it. On YouTube, you can give us a thumbs up. So we're on YouTube and audio platforms, wherever you listen to podcasts, Apple, Google, Spotify, etc. So please give us a thumbs up and reach out to me. I love hearing from my listeners, and I'm always looking for interesting guests. So if you're a technologist, a founder, or doing some interesting consulting work, I would love to hear from you. So reach out to me. I'm Tim Montague. Let's grow solar and storage. Have a great day, everybody.
Thanks, Tim.
Thanks, Tim. That was great.